Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. The only thing worse than having bad data is not knowing that you have it. With Big Eye's data observability platform, if there is an issue with your data or data pipelines, you'll know right away and can get it fixed before the business is impacted. Big Eye lets data teams measure, improve, and communicate the quality of your data to company stakeholders. With complete API access, a user-friendly interface, and automated yet flexible alerting, you've got everything you need to establish and maintain trust in your data. Go to dataengineeringpodcast.com/Big Eye today to sign up and start trusting your analyses. Your host is Tobias Macey, and today I'm interviewing Ashish Mrig about his path as a data engineer. So Ashish, can you start by introducing yourself?
Yeah, hi, Tobias. Thanks for having me on the show. So, hello, everyone. My name is Ashish, and I'm a data engineering manager at Wayfair. So, I started my data engineering journey about, I would say, 20 years ago when they used to call it database development. And when Oracle 7 was probably the cool thing on the block. So, I kind of accidentally got into this and sort of charted my career as senior developer, architect, and got into big data. And for last 8+ years, I've been managing data engineering teams. Mostly we are doing cloud first deployments, working with AWS and GCP. And I would say I work with pretty much all different types of databases, like RDBMS, MPP, distributed or Hadoop or NoSQL. So obviously there are probably hundreds of databases, but in a category wise, I've worked with most of them, and I feel like I have a good grasp on how things are aligned in the data engineering space right now.
You mentioned that you've been working in data management for quite some time now. I'm wondering if you remember how you first got involved in the space and what it is about sort of the data ecosystem and the problems that are involved that keep you interested and motivated to stay working in this area.
So I think it's more a sort of an organic evolution. As I got into the seniority, I found myself helping other team members, and it organically grew into a team lead and then as a data manager. So I don't know whether this was like a pre-designed or predestined thing on my part. So my first big break was in a company called TiVo. For those of you who are younger, who may not know that, TiVo used to be the cool digital video recording box in 90s. They were still around about 10 years ago, and when I joined them, we were in the business of monetizing TV viewership data. So we would get anything you do on television set-top box, we'll get that data, and then we would aggregate it and then make it into a product that we're selling to advertisers and TV studios. So I think that was my first big break where I was managing the big data team. The scale of the data was huge, and we were dealing with petabytes. And that was the first sort of AWS cloud deployment, working with Spark and Hadoop and all the distributed technologies. So I think that's how I got into the managing the data teams. And I found this was a very rewarding experience. I could bring a lot of experience, a lot of my sort of working in the trenches knowledge into the table and help teams and companies build a scalable and reliable architecture that is probably harder to do in data than other space.
So, as you mentioned, you're now leading a data engineering team at Wayfair, which is a fairly sizable company, and I'm sure you have a pretty significant volume of data, and you're probably hitting the maximum on all three of the V's of variety, velocity, and volume. And I'm wondering, what are some of the kind of main topics that take up a lot of your time and attention in terms of being able to keep your team on track and be able to build data products and build systems that are able to manage the sort of scale of information that you're working with?
So, as a manager of data engineering team at Wayfair, one of my job is to look ahead, meaning I'm looking 2, 3, 4 quarters ahead of the team while team is working on the current roadmap and delivering day-to-day things that people need. But I'm looking ahead and trying to not only figure out what problems we'll have, but also solve those problems in advance. And that's obviously not an easy job to do. So the thing that I typically tell people is think of the data engineering as a big lumbering ship. You can change your direction, but it takes long time to change your direction. It takes a lot of effort to change your direction. So once the ship is set on a course, moving on that course and it takes a lot of time and effort to change and chart a new direction. So we have to be careful and plan our roadmap before we start working on it. So this is a little bit different than application development where people are doing things fast and failing, right? I can't start working on, let's say, Cassandra and do things incorrectly and then fail and then come back and do things differently because I need to make sure I'm provisioning the right amount of nodes, the right compression, right compaction, the right sort of algorithms and process and design data models in place before I can even write one piece of code. So we're thinking about front loading the project or the initiative with a lot of thinking into the design, how the data should be organized, and what are the tools and processes that will go into moving the data. So once we build that process, changing it or munging it is a big task. So that's where the ship analogy comes in. So my big thing is to make sure that stage is set for the team to come in next quarter or the following quarter, do the things they want to do or we are required to do, and not be bogged down by some of the details. So I'm the, what is the word they use? I'm kind of the forward team or the advanced team that is kind of doing the recce and setting the stage for the team to come in and execute.
So, in continuing with the ship analogy, as you're trying to kind of captain the ship and chart a course, what are some of the kind of icebergs that have tended to pop up in your way that you need to work around and be able to help kind of steer in advance of so that your team doesn't run into a sort of catastrophic situation?
As a data engineer, we are almost always straddling two different words. The first word is we are engaging with the stakeholder and giving them what they need, right? End of the day, we are solving a business problem, right? We exist because there is a business that is being run and that business needs data from us. So that is our primary goal and need. And the second leg that we are straddling is the technology word. And I don't have to tell you this, especially in the big data land, the amount of technologies and services that have proliferated is humongous. So making sure we are setting the stage course for the right technology design architecture is critical. Otherwise, if we get bogged down in the second, sort of, we're not delivering on the first one, right? So that goes hand in glove. One example that I'll give you, and the iceberg that I always try to avoid, is the so-called data migration. So we went, I think almost all companies did this. All the companies, maybe in 90s, early 2000, we were all on-prem. Starting 2010 or maybe around that time, we all said we will go to AWS or Azure or any cloud. So we had spent enormous time going to cloud. And now we are into cloud, but we are also kind of stuck with one application or one vendor. So in our case, we are probably not stuck, but we are using BigQuery. But tomorrow, let's say a new technology comes around, which is 15 times better than BigQuery, then we're looking into one more data migration. And data migrations are time-consuming things, and they're hard, and they're even harder to do in cloud, especially if you're moving vendors. So I spent 6 months doing data migration from on-prem to Google Cloud, where we did not deliver a lot of value for the stakeholder. So I don't want to do that again, and that's not good for the business. So we need to think about future-proofing our architecture in a way that protects us from any new technology that, or lets us embrace any new technology without doing all the costly moves. So that is one iceberg that I always try to look out. But the flip side of it becomes a political issue in the sense that why are you trying to solve a problem that doesn't exist yet? BigQuery works fine. So and there's no new kid on the block. So who knows? We will in BigQuery foreseeable future. So that is, I think, the minefield and the icebergs that we have to, as a manager or leaders, we have to sort of straddle and work through and make sure that we are not hitting to them and taking a team with us.
The main thing, too, with the cloud adoption is that, well, it does give easy scalability of, oh, I can, pay for what I need right now and just scale up as I need to. When you do actually start to hit that scale up point, then the costs somehow seem to manage to scale super linearly. So you need to figure out, okay, how much data am I actually going to need to use down the road? What are my query patterns going to be? How am I going to mitigate some of these, unforeseen expenses that come about because of the fact that the cloud is so dynamic?
I think you hit the nail on the head. So back in the days when we were on-prem Oracle shop, we used to spend so much time thinking about the design architecture and tuning our queries because we have one box, one server, which is fixed amount of memory. We can't scale it. It takes 2 months to get a new one. And it takes almost an act of God to ask for patching and provisioning and all those things. But now everything is on demand. So you're right. I've seen, especially in the new sort of, and I don't want to make a generational war, but new generation of data engineers, that the first line of defense is, oh, let's throw more hard disk, or let's throw more memory at the problem, instead of tuning your queries or thinking about the design or solving the problem with the design. People are solving it by throwing more resources, more compute at the problem, and which invariably ends in only one way, and that way is you get an email from your head of the infrastructure or whoever is managing the resources that your infra spend is out of the roof and you need to rail it in. Until somebody puts guardrail, I think it's a natural human tendency that we take the path of least resistance. And that is another iceberg, I think, in the analogy that we, as a manager, I'm always kind of asking people and coaching people and guiding engineers to make sure that we do not go in order of code, design, architecture, and the hardware is the last resort and not the other way around. But again, that also becomes a political potato where people need things fast, and doing it the right way is time consuming. So it's a matter of fighting those battles and explaining those. But fortunately, Wayfair is the rich company, so we can afford all those hardware that Google is giving us.
From the team management perspective, because you're working with all these data professionals, you have these, high impact projects that can make or break the business. What are some of the useful lessons and strategies that you've gathered in your time working at Wayfair and other companies to help keep your engineers motivated and on target? And because of the, continually changing nature of the ecosystem, helping them to understand what are the valuable ways to spend their time, like what are the lessons that are worth learning with these new technologies, and how do you identify the cases where it's actually just a flash in the pan and it's not actually bringing anything new, it's just, putting a new coat of paint on something that's been around for decades?
Yeah, that's a really good question. And I think it's a problem that every engineering manager, whether data or any different type of software engineering discipline, has to or has been experiencing. So engineers by nature are a very opinionated bunch and very high maintenance. So I think one of the key things is we need to make sure that we are worrying about their career development, and making sure that they are thinking in the right direction. I feel like that gives them a lot of job satisfaction. So what I tell people is don't run after the next kid on the block, but have your basics, solidify your basics. What I mean by that is understand the core concepts of data warehousing, data modeling, and big data. They are still relevant whether you're using Redshift or BigQuery or Synapse or whatever else. So having that core knowledge and understanding of arranging data and what are the pitfalls or what are the intuitive understanding what makes or breaks a data project, I think that is worth its weight in gold. But at the same time, thinking about their career development, giving them a chance or giving them room to work in latest set of technologies and making sure they are marrying that chance with solving a business problem, again, worth its weight in the gold. One example that I'll give you is, as a part of career development in one of my employees, I asked them to work on building a data quality framework. As you can imagine, the data pipelines, which are munging data, have potentially have a lot of data quality problems, and we don't want to find out retroactively after event has passed from the client. So we developed this data quality framework design using, I would say, a very innovative metadata-driven data model using Python to build a data model where anybody can go in and define their data quality checks and then log that checks into some sort of tables and then point dashboards on top of that for easy consumption. So that whole project is a very ambitious thing, but it gives people a chance to flex their data modeling muscle, work in Python packages, and work with something called InfluxDB or for event logging and build the dashboards. But at the same time, we are also solving a business problem where the customers are now able to see why something went wrong or what was the extent of going wrong by doing the data quality measurements proactively on the data pipeline. As the data pipeline gets published, we are also measuring those metrics. And in some cases, we are even stopping the data pipeline because we define thresholds that if the data crosses this threshold, then let's not even publish that data, right? So that I think is a very satisfactory sort of project that people like to do, or data, especially data engineers, because that not only solves that business problem, but also expands their technical horizon and keeps them current and keeps them sort of happy with the work.
As you were talking about the kind of data quality work and the challenges there and building something in-house, it also brings up the question of, as an engineering manager and as somebody who does have a lot of background in the data ecosystem, I'm curious what your thoughts are on the modern data stack, as it were, and what are the actual useful pieces to pull out of that? What are the pieces that are not worth spending the time as a relatively mature organization on trying to kind of re-architect around, because you run the risk of, dying a death of 1,000 cuts from all of the different SaaS bills and, some of the sort of cost management aspects that go into, buying into all these different managed systems and like the kind of build versus buy equation?
Yeah, I think there are two dimensions to this question. One is the build versus buy in general for data engineering. Secondly, for a big company like Wayfair. So let me address the second one first. I think Wayfair, similar to Amazon, has, for the most part, adopted the model that if you can build it, then why buy it, right? I think Amazon has taken to extreme because they can. They're big. They don't use any commercial product because it doesn't scale for them. But obviously, we are not as big. We have things that industry leaders like Jira or Git or obviously Google Cloud Platform Services, BigQuery is of the world. Whoever is the industry leader, I think we are not reinventing the wheel there. But to your point, in terms of the current data stack, I think it lends well to solving big data problem, but it doesn't lend well to solving the process problem. What I mean is, most of the products that are being marketed right now are marketed as a way you don't have to write a single piece of code, like Snowflake or this new Cubes or new Apache sort of products. But we do want to write code because we are an engineering organization, so we are not afraid of writing code. A data stack which lends to the technical landscape than marketing to the business landscape, right? So, for example, there used to be tool like Informatica or DataStage used to do well in the client server era, but in this big data era, I would see a single ETL tool that lends well to writing your ETL as a decoupled application and then point it to any compute, whether we want to run that ETL as BigQuery process or as a Spark process or as a Hadoop process. Or maybe that's too ambitious, but I don't think that's outside the realm of possibility. Like if I express my business process as a SQL, and that SQL can transform to Hive SQL or Spark SQL or a BigQuery SQL or Redshift SQL. Why can't we build a tool like that, which is geared towards the developers? There have been few startups in this era, but we're yet to see the best to come, right? So I think that is maturing, and that is a business opportunity that is begging to be taken, building something that is platform and cloud agnostic.
Yeah, that's definitely been a recurring conversation, particularly over the past month or two for me, is the kind of question of how do we manage to build like these database agnostic processes where, DBT is taken off because of the fact that it's easy for data analysts to take their SQL skills and be able to level up into more sort of repeatable workflows by pipelining these different transformations. And that's great until you get to the point of, okay, well, now I need to do this same thing on Snowflake and BigQuery. And now I'm also going to need to run it on Redshift. And so then it's a matter of, okay, well, now I need to abstract this in Python, and maybe then I'm pulling things into Pandas data frames, so I'm not taking advantage of all the processing capabilities of the data warehouse. And so now I'm back into the old problem of I need to figure out what my distributed execution framework is so that I can do all this data processing out of band versus being able to actually make use of the data warehouse that was supposed to be my saving grace.
Right. And to throw in one more variable in this thing is, if we want to do our data processing in near real time or real time, then some of these analytical databases don't lend well to near real time data processing. And then we're talking about, if we bring in NoSQL databases like Bigtable or Cassandra or HBase, then that's a whole new problem that we have to solve, because they are not very conducive to SQL. Building a SQL layer on top is clunky at the best, I would say. I don't know if people have solved this problem. Marrying the analytical data with the events data and storing two different workloads at the same, processing two different workloads at the same time, and then make sure they're all in synergies with together, right? For most part of what I've seen is people are replicating their data models in analytical space to the NoSQL space in a different, obviously, format, because NoSQL has a different modeling techniques. And then using the NoSQL for the lookups, for low latency reads like API endpoints, and then using analytical for obviously more heavy duty processing. But then that means we're duplicating our processing and duplicating our models and duplicating data. And I don't see any cohesive technology right now that sort of streamlines it and makes it all in sync with each other. But business opportunity that's gone up again.
There are definitely some of these problems that are, as old as data itself, and there are some problems that we seem to keep creating new ones every time we solve old ones. And I'm wondering, what are some of the sort of newly generated problems that you're currently tackling, and some of the ones that have been consistently problematic for you throughout your career?
One of the things that we, maybe for past few years, is separation of storage and compute. I think I talked about this earlier as well. You can definitely put every data you have in Redshift or whatever tool that you're using, but then that ties you with that vendor and that technology. And if something new comes along, then like Presto or Druid or something, then you're not able to use that. And then if you do use it, then ending up duplicating your data and your processing. So one of my sort of pet peeves is to make sure I'm creating my data lake, or they call it as lake house or a mesh or whatever you call it, in a agnostic layer like S3 or GCS, and then point my computer. So that is problem that repeatedly keep on experiencing. And it's not that it's a difficult problem to solve. It becomes more the organization wants to spend that much resources and time to build that foundational layer in an agnostic platform, and then point computes on top of it. In other words, are we ready to be strategic than tactical? And in most companies, what I noticed is people are more tactical because there's a lot of pressure from the stakeholders, obviously, but there's also review cycle, and you need to show what you accomplished for the business, more like a quarterly stock report or quarterly earnings. So you have to be continuously showing that you are doing something and not just building these quote unquote pipe dreams that we will realize it maybe towards the end of the year. So I would say less a technical problem, but more organizational. How much organization is willing to back these? A lot of these Silicon Valley organizations are decentralized. There's not a lot of, I would say, centralized thought going into the process. Most of the teams are doing their own things. In that sense, people are taking the path of least resistance, I would say, and then doing things as they see fit. So, but the flip side is that by doing that, like companies like Amazon, Google, they have put so much premium on velocity, doing things fast. I'm arguing that is not always a right, especially in the data world, where we have to maybe pay our debt initially and do our due diligence and build our design and architecture and our lake houses before we can deliver a single report to the client. But you can't have both. You can't have velocity and then have the right idea. So we are kind of in that cycle where we are paying this debt again and again. So that's, I think, my number one sort of thing that I keep encountering. Secondly, what I encounter is writing ETL jobs, one-off ETL jobs. So if a stakeholder or client gives you some requirement, you go and build an ETL job in table. And what the end result is, your code base and your systems proliferate really fast. The complexity goes really, really fast because if you have 1,000 reports, then you end up having 10,000 tables and 1,000 individual jobs, which gets almost impossible to manage, right? Especially if you made it complex using some sort of bullshit technologies like Apache Beam, which is more a collection of bugs than a technology. So I don't know what they're trying to solve by using both batch and real time in one flow. But anyway, so my sort of problem that I keep solving is do not write ETLs as one-off things. Don't write 1,000 ETLs. Instead, write one ETL framework, which should be configurable, which should be meta-driven, and then define your business logic using SQL, which are easy to manage and maintain. And then the framework then spits out the jobs and does the work for you. So kind of like what machine learning does, but obviously not as smart. So don't write code, but write frameworks and build engines.
In terms of the architecture that you have been building out in your time at Wayfair, what are some of the kind of design choices that have been useful and some of the decision making that you've made around the kind of technology choices and where to invest your time and energy?
Back in the days, we used to, especially in the analytical world, we used to expose data in a bulk format. And most of our design architecture choices are geared towards that, to give you large amount of data reasonably fast manner. So whether by table or a file or what have you. But I think that the game has changed now. So people want not only the analytical data, but also a bit more in transactional manner. So people want to see how much, for example, in Wayfair case, what was the change in the Wayfair price for a given product? And they want to know via a service, via an API, or via a push notification. If the price of this product goes beyond $100, for example, I need to know it, right? So that's not a bulk use case. So we're not designing for two different workloads, for analytical workloads and for a bit more transactional workloads. I'm not using the word transaction in that sense, where we're doing some business transaction, but more in a event manner. People want to know, or maybe send them a Kafka message or something. So the big queries of the world don't scale well for low latency querying. And so we have to now design both the analytical and the low latency workloads. The other thing that has sort of evolved is how do we present data to the clients? And there are so many different ways to do that. I think one metric that I heard is probably still true is most people use Excel. But there are proliferation of dashboards and reporting software. And when I first started Wayfair, we were doing a lot of designing of these reports, doing the lot of front GUI part of it. And that is probably not the best use of data engineering time to design those widgets and buttons and layouts. So one of the design paradigm that we have adopted is to move out of doing that and make our customers self-reliant. So we follow the self-service BI model where we give them the analytical layer, we build a semantic layer for them, and then they can use the lookers or tableaus of the world to drag and drop the data they need and build the widgets and reports themselves. And for the customers who are not as savvy and who are mostly reliant on Excel, what we have done is we have built a multi-dimensional OLAP cube using a distributed cubing technology called AtScale. And that works really well because that has a native support for Excel and then translates into pivot table and through which analysts can do whatever they want or need. So by doing, I think, these few things, we have refocused the data engineering teams to our core competencies, which is the data modeling, the design, the ETL pipelines, data pipelines, the data quality. So I think in that way, we have moved the team away from those sort of low-performing tasks.
Today's episode is sponsored by Prophecy.io, the low-code data engineering platform for the cloud. Prophecy provides an easy-to-use visual interface to design and deploy data pipelines on Apache Spark and Apache Airflow. Now all the data users can use software engineering best practices, Git, tests, and continuous deployment with a simple-to-use visual designer. How does it work? You visually design the pipelines, and Prophecy generates clean Spark code with tests and stores it in version control. Then you visually schedule these pipelines on Airflow. You can observe your pipelines with built-in metadata search and column-level lineage. Finally, if you have existing workflows in Ab Initio, Informatica, or other ETL formats that you want to move to the cloud, you can import them automatically into Prophecy, making them run productively on Spark. Learn more at dataengineeringpodcast.com/prophecy. And another interesting aspect of the current landscape of the data ecosystem, and particularly data engineers and data platforms, is we've moved beyond just the need for answering analytical queries with our data to the point where we actually have to start managing more large-scale machine learning workloads and maybe being able to handle reinforcement learning and being able to manage the feature engineering and low latency queries and, real-time aggregation of that information. And I'm curious, how are those demands starting to manifest in terms of the work that you're doing and the ways that you are thinking about steering the ship to be able to enable both the analytical use cases that have been, evolving and I'm sure largely mature and stable, alongside the requirements that various machine learning workloads are placing on your team and your infrastructure?
There are not so many different types of stakeholders that I don't think we should even call ourselves an analytical platform. So machine learning and data scientists are obviously the key ones, but funnily enough, the engineering teams through which we source our data, they are also our customers because they need to also consume some of our data that we are gathering and building as a historical source of truth to do some of their data processing or transactional processing, application processing that they're doing. So that's also another use case where we need data in more transactional manner. Well, whoever is our customer, the underlying paradigm still remains the same, that design is the king. That is what I keep telling people. Don't be reliant on processing power of BigQuery or Redshift, but design it properly. Meaning, for example, data scientists, they're looking for a huge amount of data to train their models. I would say lends really well to the data warehouses and data lakes we have, but they are looking for data in different formats, different sort of grain, different cadences. So building a mart for them, building some sort of subject area or a gated community that they can access data, I think that goes really well, but they need access to historical data, and our storage is cheap, so we keep the data for however long they want it. Similarly, for our application teams, they need to do a lot of, I would say, searches and a lot of figuring out the data, sort of proverbial needle in the haystack. And so another sort of design approach you're taken is to publish it in a distributed search engine like Solar, where once you throw the data in that engine, people can then use it to perform searches and cross-reference the different types of data and then use whatever they need. Instead of building APIs, we have defined API engines or API services where any query can be exposed as an API endpoint by just doing configuration changes in a configuration file. So by doing those repeatable patterns, we are able to, I think, scale in a serious manner and not have to write a lot of code. If a client needs a new data set that they want to search on, then we can just plug it into Solr, and then they can run from that. And similarly, API endpoint, we can define new API endpoint, they can define query, and then they have voila, a new API service to grab data from. And similarly, on the data science front, again, we are driven through frameworks and models. We define the data sets or define the processing in a framework. And if you need new data from us, our data lake has everything, obviously. But if you need new data from us, then we define your load as a metadata. We express as a metadata, and the engine will then execute a metadata, which in turn is expressed as SQL for the most part, but there are exceptions. And then translate into jobs and run the jobs and grab the data and automatically load your data marts that you need. So in that way, we are scaling our systems in a very sort of logical and organic way. We are, as the customer needs and the customer base increases, we are not bogged down in writing new code. I don't have a large team, so necessity is the mother of invention, right? So we are writing the scalable, repeatable, performant solutions or models where people can just grab data programmatically.
In terms of the kind of pitfalls that your team has run into where maybe they didn't do enough upfront design, or whether it's in your work at Wayfair or in previous organizations, what are some of the kind of common blind spots or pitfalls that you and your team have run into?
Yeah, so I think I mentioned this, using hardware as the first line of defense. That always comes to bite you back. Even in cloud, there's so much hardware you can throw, and not thinking through the design is another pitfall where people are just writing code or going in as like a Uber coder, not thinking through the design. I may be repeating myself as a broken record, but design is the king, and not thinking through design enough is another sort of pitfall. And then running after tools and technologies which are not established themselves and not thinking about the support. So for example, if I bring in a new Google service called Dataflow, which is like EMR, then that's not a managed cluster. I have to manage the cluster myself. Then how am I thinking about supporting the cluster? What if things go wrong on Saturday at 5 p.m.? What is my support? And who's going to resolve my problem? That means I need DevOps. I need a roster of people who are on call. So thinking through some of those things, that in terms of support and maintenance and figuring things out on the fly. One other thing that I also want to point out is that when designing solution, especially data pipelines, people don't think about reliability. They don't think about how to play a pipeline automatically when things go wrong. Most people I've known, they code for the best case scenario. Okay, we have data coming in, and this is our ETL transformation, and then loading it in target table. But what happens if your data doesn't come in? What happens if your data is missing or incorrect or has gaps? Or what if you produce a report that goes to senior management but is giving them wrong information? What happens then? What happens if you find out the problem 3 months after it happened? How do you go back and replay it? So having that automated replayability is absolutely essential, which most people I know, they don't. Unfortunately, a lot of people do, experienced people, but most of the people, they don't plug into their design when they're designing. Ends up happening is they would have to spend huge amount of time manually to correct those data problems and replay the data themselves, which is a huge sink on their time, and that time obviously we're not delivering value to the stakeholder. So the first thing that I look for when I look at a design is what happens when shit hits the ceiling, and how do you recover from that?
Another interesting avenue of your experience is that you're helping to run a data engineering meetup for the community local to you in Boston. And I'm wondering, in your work with running that meetup and talking to the folks that are showing up there across the different organizations, what are some of the recurring themes that are coming up and being discussed, and some of the either common pain points or some of the interesting successes that folks have discussed?
Right. So I would also point out that I run a meetup called Data Engineering Boston, and I also write a blog on data engineering blog on Medium, which has a good number of followers. And I'm also teaching a data analytics course at Brandeis, which is a local university in Boston. So I'm interacting with a lot of people, and it's interesting to see that a lot of the times the problems they're trying to solve are problems that they have been solved before. So, for example, most of the workload that people have, they're not living in Redshift or BigQuery of the world. They're living in SQL Server or Postgres or Aurora. That's the most common databases people are using. So they're having problems in terms of concurrency or performance or scaling, and figuring out things like simple things like you have a Parquet file. How do you do schema evolution? Parquet has a schema evolution feature, but that is expensive. That slows things down. So how do you solve it by design? So then, for the most part, people are having this sort of common problems, and I feel like there is a book that needs to be written, is begging to be written, maybe someday if I have time, that kind of explains those kind of things or simple problems that people are having. And I think they're looking for a support community. There are some people who are looking to break into this field, but for the most people, they're looking to have support because there's so many technologies, tools, and platforms. It's just virtually, obviously, impossible to be good at everything. So they're looking for expertise when they're struggling, and they're looking to unblock themselves, and they're looking to get ahead in the career. And they're trying to also figure out, oh, I'm a data analyst. How do I become a data engineer, or how to become a data scientist? So they're looking to also see how well they can progress in their career. What are some of the courses or technologies or certification they can do to do that? So there are all different kind of people out there, obviously, but it's very interesting. At least to me, I was shocked to find in my bubble, I thought the analytical databases are probably the most used, but they're not. It's the SQL Server and the Auroras and MySQLs of the world that are obviously more commonly used on the data world.
Yeah, it's definitely interesting, the stickiness that these transactional systems have. And I think part of it is that operationally they're very well understood. So if you have an application team who can stand up a database and use that for writing a general CRUD application, they're going to be able to do the same thing and just use it for their analytical workloads until they start to crush the database because they're trying to do aggregate queries on a row level storage. So
even then, I would say these databases have done a good job. At least, like if you have low terabytes of data,
right,
they can easily scale. Like SQL Server, Oracle, or Postgres, they can easily scale up to low terabytes. And for most companies, I would say, even though big data is a buzzword, most companies don't have hundreds of terabytes. So these databases can easily handle that. And even though they are OLTP, they can easily do reporting, aggregation, and all those things. You can easily solve by design. And secondly, there's also like a sweet spot in between where somebody like AWS Aurora has come up and has offered some of those features where they offer you distributed compute and they offer you storage compute, but they also offer you ACID, and they also have OLTP workloads. So they're offering kind of best of both worlds. And they can scale up to, I don't know, 40, 50, 60 terabytes. So then why do you even need the Redshifts of the world and pay that high cost? Right? Because if you have a mixed workload, then Aurora can easily solve the problem. Why go for a BMW when a Honda Civic will do the job, right?
because driving a BMW is fun.
But you have to pay for it.
Exactly. Yeah. There's definitely a lot of the kind of, I don't know if it's the sort of fear of missing out or just cargo culting of, oh, I'm doing analytics, so that means that I automatically need to buy Snowflake for my, 5 gigabytes worth of data. Age-old problem of crushing a fly with a bazooka.
Oh, yeah. By the way, Snowflake has the best business model where they don't tell you why they are spinning up clusters, but they'll spin up new clusters all the time for your data workload. And the more clusters they spin up, the more money they make, right? So I should have bought this stock.
Why are they launching a new cluster? Oh, because they, they need to pay their employees stock options or what have you.
We should have all bought their stocks, right? So
yeah, absolutely. And so in your experience of working in the analytics space and managing a data engineering team, what are some of the most interesting or unexpected or challenging lessons that you've learned?
So I think as you grow in your career and as you grow sort of in your team organization, you realize that most of the technical problems are relatively easier to solve. And maybe I'm giving you a little bit non-political answer here, but most of the problems that are kind of hard nut to crack, so to speak, are political problems, organizational problems that require maybe a lot more weight than you can bear on. So, for example, in a decentralized company like Wayfair, there is no such thing as office of architecture, right? So nobody's thinking through data architecture. So all the teams internally themselves are doing what they can, but there is not enough weight that is being put on data architecture as a discipline. So as a result, all the decentralized data teams are doing whatever they can. They're doing the best they can, obviously, but there's no competency, and as a result, there's not much gravity there. So I feel like we have missed a step there by not thinking through that. But obviously, if we do that, then we are slowing the teams down. If you have a office of data architecture, then office is mandating few things, and that slows people down. Those slows them down. And as I said, Silicon Valley companies have put a lot of premium on the velocity. So it's kind of chicken or egg. I still feel like there is maybe a happy medium there where we still can have some people thinking about data architecture while not slowing teams down, and that would give people benefit in the long run.
As you continue to work through the challenges that you're facing and chart the course for your team and your organization over the coming, months and quarters and years, what are some of the topic areas that you're most interested to dig into, or some of the sort of aspects of the data ecosystem that you're keeping a close eye on?
Yeah, I think there are a lot of good things that are happening, obviously. So I think one thing that we are looking at is how do we break some of those barriers between machine learning and databases. Right now, we have to build a separate, I would say, a data structure or a data mart or what have you, semantic layer or curated layer for our machine learning or data scientists. And then they sort of point the models on top of that. So having your model point right to where your analytical database lives and makes that sort of selection within that tool and reduce the barrier, and having all those algorithms natively talk to the database, I think that will be huge. Secondly, I'm also looking at the OLAP space, which used to be big back in the days. If you remember the SSAS cube of Microsoft. And in the big data world, that technology is, I think there are a lot of interesting players. I think there is Apache Kylin, which is on Hadoop space, and AtScale, which is more on the distributed technology space. So it will be huge to have that technology mature and give people a good multi-dimensional data structure to play with, especially in the big data world. We have so much data proliferating, so having that technology is good. And then having a technology which can run both the analytical and real-time workloads together. I'm not talking about transactional, but I'm talking the near real-time loads is again something that I'm keeping an eye on. And obviously, Spark and Hadoop and Python, and having like a next sort of ETL technology or paradigm, which is more agnostic of platforms and clouds and technologies. Also, I'm looking at. And then finally, I would say data quality. I feel like data quality is kind of the stepchild of data engineering. People haven't focused as much, but we spend so much time looking or worrying about data quality that it's not productive to not do it upfront. And it's mostly a build. I can't buy anything right now. So those are some of the things that I'll be looking at.
So for anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
So I think I mentioned some of the things, data quality and ETL frameworks and machine learning organically and all those things. Yeah, so obviously technology is evolving as we grow, building much more scalable, much more reliable, durable performance systems is as much fun as it is now as it used to be back in the Oracle 7 days. I remember my first data warehouse was 700 megabytes. I used to think that's huge, and it's almost funny to think about right now.
Yeah, absolutely. All right. Well, thank you very much for taking the time today to join me and share your experiences of working in the space and managing a team that's powering a large organization. It's definitely very interesting and constantly evolving problem domain. So it's great to hear the experiences of people like you who are working in it day to day. So thank you again for taking the time and for all of your efforts. And I hope you enjoy the rest of your day.
Thank you.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.
La 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 la